Okay, so in this video, we're going to be talking about one-step equations and how to solve one-step equations. Now, we're going to start getting into things like two-step equations and multi-step equations, but before we can do that, we first must understand what it is we're trying to do when we have an equation. And the first thing to understand, I know that I'm dealing with an equation because I have an equal sign. So if you look at number 1 and number 2, this is no longer going to be considered an expression. This is now an equation, right? And again, I know that because I have an equal sign. Expressions do not have equal signs, okay? So I know that on number 1 and number 2, I'm dealing with an equation here. So our first step when solving an equation is we want to try to isolate the variable. So if you look at number 1, I want this problem to say x equals, okay? Not 5x equals. I want it to say x equals. So my job here is to essentially take this x and isolate it, right? I have to figure out how I can do that. Now, in order to solve equations, you have to know inverse operations, okay? And I wrote them down here. So if you have addition, we know that the opposite of addition is going to be subtraction, right? And if you have multiplication, you know that the opposite is going to be division and vice versa, right? You can go in reverse. Subtraction, the opposite is addition. Division, the opposite will be multiplication, all right? So the way that I teach this is to essentially cover up the variable. Okay, so if you were to take this x and essentially cover it up, so if we were to cover that up with our finger or our hand, we see that we have this 5 here. We have to get rid of that 5. Now, how do we get rid of that 5? Well, look at the operation that's taking place here. It is 5 times x. So what is the opposite of multiplication? Because that's what we have here. Well, the opposite of multiplication is going to be division. So essentially, by doing these inverse properties, you're going to undo the equation so that you can essentially just have x equals. So if I have 5 times x and I'm trying to get rid of this 5, I am going to divide both sides by 5. Okay? Now we have to do both sides here. And when I say both sides, I'm talking about on each side of the equal sign, right? You know, some instructors may tell you to draw in a fence here. That way you know that you're balancing it out. So if you draw a fence right below your equal sign, just a vertical line, right? You know that you are in fact balancing it out. What I do to one side, I have to do to the other. I typically don't do that, but that could be a helpful tool to help you get through these problems, okay? So definitely keep that in mind. Now, what's going to happen here, wherever you do the operation first, so I divided by 5, it's always going to cancel out where you did it first. So for example, right here, this will naturally cancel out. And we know that's going to be true because 5 divided by 5 is 1. And then you're just left with x here. It's 1x. And that's exactly what we want. We want to isolate x. So here on the right-hand side, I'm going to divide by 5. So 10 divided by 5, I get here x is equal to 2. Okay? And that's going to be my final answer. Now, if you really want to, you could check it. How do you check it? You go back to the original. And wherever you see an x, you're going to plug in a 2. So I'm going to do 5. And remember, this is multiplication. So I determine that x is equal to 2. So I'm going to plug in a 2 here. And I'm going to multiply. And you have to say to yourself, is that statement true? 5 times 2 is equal to 10. 10 is equal to 10. That is a true statement, right? So you can check your work to make sure you did it correct. Now, if you do this part right here, where you insert it in or you substitute it in and check, and it comes out wrong, you know that you did something up here that was incorrect, and you're going to have to go back and try to solve the equation, all right? Now, typically, I do not check them, but this is something you can do to help you confirm that you're on the right track and that you are, in fact, doing it correct. Now, something to keep in mind here, right? Before you try to isolate x, you have to make sure that the equation is simplified down, okay? So in order for it to be simplified down, I have to make sure that I don't have to distribute anything or combine any like terms. So on number 1, okay, I didn't have any like terms to combine. I didn't have to distribute. This thing was ready to go, okay? It was all simplified down and I was ready to isolate the variable. There will be some more problems in this video where that won't be the case and we'll have to work through it, okay? It'll be more like a bonus problem. So stay tuned for that at the end. That will be the last problem. So let's go to number 2. What is the operation that we have going on here? I have x divided by 12, okay? What is the opposite of division? Well, it's going to be multiplication. So remember, the goal is to isolate x. How do I do that? Well, if it's division and I want to get rid of this 12, that means I have to multiply both sides by 12. So I'm going to go ahead and rewrite this one. It's x divided by 12 equal to 2. Okay? So in order to isolate x here, I have to multiply both sides by 12. Okay? And I have to do that on both sides. Remember, we have to balance it out. Okay? So what happens here? Well, again, I told you at the beginning, wherever you do it first, it will always cancel out. So right here, this will cancel out. And again, you can prove that out. You can see that I'm going to end up with 12x over 12. The 12s cancel. I'm left with just x. That's what I want. But you don't even have to do that. You just have to remember that wherever I do the operation first, it will always cancel out there. Okay? And right here, I'm going to do 2 times 12. I get 24. So x is equal to 24. Okay? If you really wanted to, you could plug that back in, and we can do that in our head mentally, right? If I plug a 24 here into x, I get 24 divided by 12. Yes, that is equal to 2. I did do it correct. Okay, let's try a few more problems here. Okay, so here are some more problems. Let's go ahead and take a look at number 3. You can see that I have addition, right? My goal is to isolate x. So in order to do that, I have to do the opposite of addition, which is going to be subtraction. What are we trying to get rid of? Well, we're trying to get rid of this positive 15. So what we need to do, we need to subtract both sides by 15. Again, if you need to, draw in your fence right below the equal sign, just the vertical line, and that shows you that you're balancing this out, right? So minus 15 here and minus 15 here. Okay, that's all we're doing. And so we're going to go ahead and do this out now. So this x is going to come down. I bring down the x. And then again, wherever we did the operation first, it always cancels out. This is gone, okay? And then equal to 21 minus 15, well, that's going to give you positive 6, okay? And we're done here. X is equal to 6. Let's go ahead and check it using mental math. If I do 6 plus 15, does that give me 21? It does, right? We did it correct, okay? Let's take a look at number 4. Again, here we have subtraction. What is the opposite of subtraction? It's going to be addition. Okay, so I'm going to add 12 because, again, that is what I'm trying to get rid of. I don't want that there. I just want x, right? So we are going to add 12 on both sides. Do the fence if you would like. Okay, so adding 12. And this will cancel here. We talked about that. That will always cancel out where you do it first. Here we're going to bring down the x. Bring down your equal sign. 24 plus 12, well, that's going to give you 36. Okay? And this problem is now done. Let's double check it using mental math. 36 minus 12, does that give you 24? It does, right? So we can confirm it. All right, let's try one more problem, and this is going to be a bonus problem. Okay, so here is our bonus problem, and this one is actually not a one-step equation, but maybe you can do it, and maybe you can try it, right? So remember what I told you. In order to start isolating the x, you have to make sure that the equation is completely simplified down, okay? And this one here is not simplified down because I can take this 2 and I can distribute inside, right? Further simplifying it down. So what you don't want to do here, okay, and this is a common mistake, you don't want to say, okay, I'm going to minus 6 here on both sides, right? That's actually going to be incorrect. So please don't do that. You have to make sure that the equation is simplified down first before you try to isolate the x, okay? So on this problem here, again, it's a little more challenging. We're going to take this 2 and we're going to distribute inside. So when I do that, I get 2 times x, I get 2x. 2 times 6, I get plus 12. Okay, equal to 6. So what you actually have right now is a two-step equation. So we're going to do the same thing that we did before in the other problems. We're going to pretend like we're covering up this x here. And what do we need to get rid of? Well, I have this 2 here, right? I have a 2, so I could technically divide everything by 2. But essentially what we want to do, we want to save this part for last, right? Whatever the x is attached to, we want to save that for the very end. And some instructors actually teach PEMDAS in reverse. So if you remember PEMDAS, right? If you're having trouble figuring out what you need to do next, you can think about PEMDAS, and you're essentially going to be doing it in reverse. So if I go in reverse, that means subtraction and addition comes first. So once you simplify down the equation, I see that, okay, what do I need to do first here? Well, I'm going to have to take care of this addition, right? Because if I do PEMDAS in reverse, that's what it's calling for. Then I have this multiplication and division, then it goes up to exponents in parentheses. So that's a technique you can use if that's helpful, all right? But as you progress, it's going to be like second nature. You won't even have to think about it. But in the beginning, using PEMDAS in reverse isn't a bad idea. Just make sure, again, that the equation is completely simplified down before you do that, okay? So let's go ahead and do this problem now. So I'm going to get rid of this here. And we're going to go back and we're going to solve now. So I know that I have to do addition first. And again, you can use PEMDAS in reverse to determine that. So I'm going to minus 12 on both sides. Okay, if it's helpful, again, use your fence so that you know that you have it balanced out. I'm good. I'm going to bring down my 2x. Wherever I do the operation first, it cancels out. This is gone. 6 minus 12 is going to give me a negative 6, right? So now we have it down to a one-step equation, just like the other problems. You can see that I have multiplication here. That means I'm going to divide by 2. So I'm dividing by 2. Okay, this will cancel. Here I get negative 6 divided by 2. So again, you're dividing a negative by a positive. The result is going to be negative, and it's going to be negative 3. Okay, this is it right here. X is equal to negative 3. So that was actually technically a multi-step equation, because before we can bring it down to a two-step, we actually had to distribute the 2 here. Now, this problem could have actually been a lot easier. I'm going to show you a little trick here. So we're going to go all the way back to the beginning. So just deleting this stuff here, let's go all the way back to the beginning, and I'm going to show you a little trick here. So rather than distributing the 2, let's get rid of this right here. So again, rather than distributing the 2, you can see that the operation here is multiplication. It's 2 times everything inside. Okay, so let's think about how we can get rid of that 2 rather than distributing inside. Well, the opposite of multiplication is division. So if I simply just divide this whole thing by 2, okay, this will cancel out here. And again, I do have to balance it out. Okay, so I'm going to do it on this side here. And now I can go ahead and solve it. Here I get x plus 6, right, equal to 6 divided by 2. That will give me 3. And you can see that it's already a one-step equation now, right? There's less steps in this method. You don't have to do it this method, but if you can recognize it, it's going to make it a lot easier. So from here, this one-step equation, it's addition. The opposite is going to be subtraction on both sides, right? And you can see here that we are going to get the same answer. 3 minus 6 is going to give you negative 3, exactly like we got before. All right, so that is another method in which you can solve it. And honestly, that is the easier of the two methods, okay? If you can remember it and if it's not too confusing. And so again, if distributing that 2 is easier for you, go ahead and do that. It's not a big deal. You're going to get the same answer in the end. But again, we should do a quick check here. Let's make sure that it is in fact correct. So we're going to do 2, and then in parentheses, we're going to substitute in x. We have a negative 3 there. That's what we found it to be, plus 6, equal to 6. So again, using PEMDAS, we have to do the operations inside parentheses first. Again, this time we're not going in reverse though, right? So negative 3 plus 6, we're going to get positive 3, equal to 6. And you can see here that 6 is equal to 6. This checks out. We did do it correct, so that problem's done. Okay, so that is solving one-step equations, and you actually even had a bonus problem in there, which was actually a multi-step equation. So good job if you were able to handle that. But if that was confusing, it's not a big deal because we just started talking about one-step equations. So if you could do the problems before this, you're in great shape. And so again, if you found the video helpful, please go ahead and give it a thumbs up. And make sure you subscribe so you get more math videos in the future. And I'll see you in the next one.